Welcome to our next complex numbers video, our second video about the remainder and factor theorem. Right, so we got up to in the last video talking about a factor and remainder theorem, and let's see if we can keep continuing to explain what this is all about. Here's our polynomial. X is equal to x squared minus 11x minus 26. And we're going to determine if x minus 13 is a factor of the polynomial. We're going to substitute in 13 into the polynomial. If it's x minus 13 is the factor, then we substitute in positive 13. Remember, the factor theorem says if x minus a is a factor, then we substitute in a to get 0. Let's substitute in 13 to get 13 squared minus 11 times 13 minus 26, and I get a value of 0, which shows us that x minus 13 is a factor of the polynomial. Keep going and see if we can determine if x plus 2 is a factor of the polynomial. To do that, I need to substitute in negative 2 into the polynomial and work out p of 2. That's because the factor is x plus 2. So let's go negative 2 all squared minus 11 times negative 2 minus 26. And again, I get 0, which again shows that x plus 2 is a factor of the polynomial. Now, for a quick moment, I'll take a short break and talk about something else. That means I can factorize the polynomial into factored form, which is a really cool technique. Let's keep going and talk about whether x plus 4 is a factor of the polynomial. So, if I want to work out if x plus 4 is a factor, I need to substitute negative 4 into the polynomial. To do that, I go negative 4 all squared minus 11 times negative 4 minus 26, and I get 34. So p of negative 4 is 34, which is not 0, which means it's not a factor of the polynomial. Hence, if I took the polynomial and divided by x plus 4, I'm going to end up with the remainder, because they don't, in fact, when I divide by a factor, I get a whole number, another factor, but when I divide by another number, I get a remainder. And in this example, I get a remainder of 34. You might remember back to our previous video or two ago where we showed you how to do algebraic long division. And this is another strategy to help you work out the remainder when we divide algebraic terms. Let's push on to our first example, official example of the video, and show you a question. Show that 2x minus 1 is a factor of the following cubic. If 2x minus 1 is a factor of the cubic, then we need to substitute half, 1 over 2, into the polynomial and get 0. Now, why 1 over 2? Well, normally, if it was minus 1, we would substitute plus 1 into the polynomial. But we also now have to divide by the 2 to get 1 over 2. So we're going to substitute half into the polynomial, and I've done that, and I get a value of 0, which tells me that p of half is 0, which tells me that 2x minus 1 is indeed a factor of the polynomial. So I've finished the question, but I'm going to carry on from here. We know that the polynomial, the cubic, can be factored into 3 factors, 3 brackets. We now have managed to find the first factor, the first bracket, 2x minus 1. I'm going to keep going and see if I can find the next 2 brackets and show you that this is a cool trick to factorize polynomials. I'm going to substitute p of 2 into the polynomial, and p of negative 2, and p of 3, and p of negative 3. Now notice I get 0 when I substitute in negative 2, so if I've done that, I know another factor is x plus 2. And notice I also get 0 when I substitute in negative 3, so I know another factor is plus 3. So I've found my 3 factors for this cubic and written it into factored form. Now, one last thing is I hope you know that these numbers here, the numbers all multiply. Negative 1 times 2 times 3 multiply to negative 6, which means I'm not randomly guessing what numbers I substitute in here. I actually are thinking about the factors of negative 6. Right, that's us for the video. Thanks for watching.